And so please don't take anything that I or we say today to be like, whoever wrote this is an idiot. They focused very clearly on the goal of delivering the features that they wanted to have, and they delivered on, and they succeeded at that goal. We can today use that in the context of their success to try and serve the second goal, try and improve the quality of the code, make it cleaner, make it more resilient to change.
Can I add a couple of
Yes.
things? This software project started in 2006. In 2006, we really did not know, as a community, as a Ruby, or in particularly a Rails community, we did not know which things would hurt us farther down the road. We were making a lot of choices that we just had no idea whether or not it was a good choice. So this project has not only solved the problem it set out to solve, it's also survived. There are 200 forks of the project. It's in active development. They keep releasing new versions. They upgrade. There are a lot of people using it, and it's in many ways a success story, even though it has some of the growing pains that long-lived projects have. Sure.
And projects like this, I think when people are new to the community and they have this idea of like, open source is cool, I want to contribute to open source, I'm going to think about Rails, and I'm going to imagine some new features Rails needs. And then when I never come up with that idea, I will build it and I'll contribute it back to Rails. Right? That's an exceptionally large jump to try and make. It is much more practical to find an open source project such as this. You probably have things to do in your life. You have some kind of system for it, but you could try out this system and then kind of get the benefit of eating your own dog food, right? You could download the app, run it, make some improvements to it, and contribute it back. And once you learn about the processes that go into that, you're much more likely to be successful at contributing to larger projects like Ruby itself or Rails itself. So, I'm Jeff Casimir.
I'm Katrina Owen.
We have a company called Jumpstart Lab. We teach technical training for companies, so like 2-week-long classes, and much of our time right now is spent teaching a 6-month developer training program in Denver called G School. Previously, we ran Hungry Academy at Living Social. And this is our workshop. So why do Rails projects go wrong? Why do software projects go wrong, right? The chorus on why software projects go wrong is communication. It's always communication problem. For projects to really burn down, you have to have communication problems that lead to those mismatches between expectations and reality. But when you look, let's say we have clear expectations. Let's say we have good communication. Rails kind of sets you up for trouble. And I want to look at why that is. Let's talk first about the MVC theory and how it should work. Your application receives a request. From there, it trickles down to the router, to the controller, controller to the model, model over to the database, database back to the model, up back to the controller, through the view, output a response. So request, HTTP request with a verb and a path comes in, it hits the router. The router decides who this belongs to. What is the user trying to do? It passes that information on to the controller, and the controller is now the middleman. Ideally, the controller has almost no responsibility. It is just receiving information and dispatching information to other parts of the system. Controller takes the information it needs from the router, passes it down to the model. The model does the smart, interesting stuff, right? The real programming. Talks to that database, gets the data out, formats it, puts it into Ruby objects, passes those back to the controller. The controller then prepares that data for the view template, and this is a little bit idealistic model. This is not exactly how it works, but let's say that the controller kind of passes its data to the view. The view then injects that data into the template, creates a plain HTML response with HTTP headers, and shovels it out to the user. That's the idea of how it works. This area down here is pretty clear. People agree about how it should work. and what it should do. The code behind it is the part that over time has changed the most in Rails. Active Record has probably seen more work than any other component of the framework. And part of that is because I think it is a clearly understood problem. You know what an ORM is supposed to do if you're a Rails developer. And so you can hammer on the library, make it do that faster, make it do it better, make it do it more flexibly. Up in these layers, there really hasn't been very much change. If you were to take a Rails 1.0 app from 2006, your controllers and your views would work out of the box. There are things that have been added since then, but really we haven't improved much of the thinking. If we make it a little more realistic, each of these items that's supposed to have one responsibility actually has at least two. On the way down, the controller is responsible for processing the request, pulling out those parameters, figuring out more about what needs to be done, passing that down to the model, and the model then starts doing the database communication. And then typically, once it has fetched information from the database, there's a second responsibility in there of business logic, right? Doing interesting stuff with that data. It then sends that data back to the controller, and the controller acts as this funky data interface to the view template. It's one of the things I hate explaining in Rails is how does data get from a controller to a view? Well, you make it an instance variable. Okay, say more. Well, it works. It's fantastic. Okay. The reality that you don't want to know is that the controller instantiates another class, another instance called a view context, but don't look for a class named view context because it's an anonymous class that's like created on the fly, and it queries itself for its instance variables and then passes all those instance variables into the view context, and it's like a really jacked up system. If you ever want to be terrified by this, go into a view template, any request, and do ERB tags, %= self.inspect. And you'll see, I think last time I did it, it was 5,700 characters of information. And you'll see in there like the same things embedded multiple times, same HTTP parameters and all. It's a really crazy shit show, for lack of a better word. So hopefully one day, maybe some of you will fix Action View and make it not suck. I shouldn't say suck, because it works, right? Make it easier to understand, easier to pull apart. But if there's one area that causes the most problem in Rails applications, it's this, the controller. And to say it has these two responsibilities is really an oversimplification. It really has somewhere around 12 responsibilities in a typical app. It's doing everything. It is effectively the God object of your request. It's responsible for setting messages, queuing jobs, sending stuff to a cache store and fetching it back, determining what kind of response the user wants, etc. All these things are, according to MVC, these are at least plausibly the controller's responsibility. And anytime you have an area of code that has 12 responsibilities, it is going to get out of control by nature, unless you fight very hard against it. And so, despite the talk of, fat model, skinny controller, that in itself is not a solution, but the premise that controllers should be concise is a goal that we should always push towards. If your controller method is creeping up above about 7 lines of code, you probably need to rethink how you're doing it. Many controller methods, and some that you'll see today, are dozens, maybe even hundreds of lines of code. Particularly what you see this with is the parameters. If I've got this parameter and this parameter, do this one thing. But if that thing didn't work out, do this other thing. Or if I have this other combination of parameters, do this other thing, and do that other thing, and da-da-da-da-da-da-da. There are many reasons for that complexity. We'll look at ways to reduce some of them today. So refactoring, I feel like I shouldn't even say refactoring when you're here. Like this is like Katrina's wheelhouse, but I made the slides, so I get to say it. Refactoring is a word that we love to throw around in the Ruby community. Comes from refactor, and it simply means changing shit, according to many people. Like, it means judging other people's code. Sometimes that other person is past self, and be like, that person was an idiot. I can't believe they wrote this. I'm going to change some stuff. And perhaps it will be better, right? But in reality, there is a process to refactoring. It is more than just changing shit. And one of the reasons that we can follow this process on tracks is specifically that tracks ensures its external behavior. The critical piece about refactoring is that from the business side, that left side, or top side, that customer desire, refactoring provides no value whatsoever. Customers don't pay you to refactor. What they do pay you for, or you pay yourself, or whoever's dishing out money, is that when you dream up the next feature, you can build it in what seems like a reasonable time without burning down the house. And that's where refactoring provides value. To refactor effectively, you show no external change. And it's only possible when things work. If something doesn't work, you cannot refactor it. Okay? And so it is always okay. One of the things we always push students towards, and they kind of hate it, is doing the dumbest thing possible, right? Just make it work, and then make it better. If you try and make it correct on the first try, you'll probably never get there, right? It's more important to write a crappy implementation of something and do it in a smart way where you're covered by tests that ensure the expectations, ensure you're delivering the value you want. And then you can make the code better. There's always time for that. You have to have that test coverage. And defining now well-tested is like a whole nother workshop. Hopefully, if you're interested in that topic, you came yesterday and heard some great talks from Thoughtbot and from Noel. That's a whole nother layer of complexity. But thankfully, in this situation with tracks, it's plausibly well-tested. It has acceptance tests and so forth. Our goal is to increase the ability to change, increase the agility of the code. That typically means breaking it into smaller chunks that can then be recombined in interesting ways. So tracks. I don't want to talk anymore. Thankfully, Katrina put together an incredibly detailed tutorial for you. And especially on day 3 of the conference, maybe you were Pivotal Labs boozing it up last night, or whichever party was last night. Maybe playing board games, you're being very responsible. You're probably better off programming than you are listening to me. So, if you weren't here when I started off, we have an alternate Wi-Fi network named On Ails. If you connect to it, you can actually use the internet. If you would hop over to railsconftutorials.com, down in the Wednesday section, you'll find a page for this session. And in that session I will approximate 12 days of work for you. I don't know, Katrina went off writing tutorials on you all. So you will not finish it. You probably won't get halfway through. What I hope is that you can dig in and start to get an idea of how you can apply these principles in code, and then maybe take it with you and continue to work on it in the next days and weeks. We're going to float around and answer questions. I think anybody else doing question answering, can you raise your hand? There's at least one. Yes. So also, please try and make use of the chat room. I know people haven't really used the chat room because the connectivity sucked. Now that we have connectivity, hopefully you can use the chat room and you can answer each other's questions in there. We'll do our best to pop around, and we'll do a little wrap-up at the end.
We may also just kind of duck up for air every 15 minutes or so, just to see how you're doing, if there are any questions. I'm guessing that if one of you has a question, about 80 of you have a question, so it would be good to get them out loud. And there may be concepts that it would just be good to talk about. So we can take breaks. You don't have to refactor 100% of the time. Like Jeff said, the tutorial is pretty detailed, so you may be able to just finish it on your own, also not here.
And you're strongly encouraged to work with somebody else. They're probably nice people. If anybody's mean, we
talking
can
about
point them
things
out.
you're wondering out loud is very helpful in two ways. First, you get to hear your own voice say it, so you actually get to sometimes answer your own question because you hear it through a different sense. Sometimes it also helps us overhear questions so that we know what to talk about up here.
I would go so far as to say, if you would kindly, when you have a question, ask at least one other person before you ask us, because you're both helping yourself in possibly answering your own question and helping them with a slightly deeper understanding. So. It's on the page. If you go, it's like the top section on the page. Oh, I got you. Yeah, because this thing's not interesting. And then people will like be putting up all kinds of meme photos and stuff, whatnot, I'm sure. All right, go to it. There's a question answerer, this masked man. So, sorry. Good plan. Didn't really work out, I guess. The router is fine, but it's like outside the router. Traffic's just dying. Like, I'm only 1 out of 5 of my packets is getting out, and I'm connected to the Ethernet, which sucks. So it's not. And looking at pieces, I don't think there's yes. I don't, based on what I see, I don't think that's the issue. I only see like 100 clients on there, which is about like the size of the room, or 80. Yeah, so I thought about that. What I think I want to try is Katrina is going to work through some of the exercise here, so we can at least look at it, discuss it, because I worry that, yeah, if it's like USB, we're going to just spend an hour passing USB sticks, you know. And so sorry that sucks. We thought we had a good solution. Turned out it didn't work. While she's starting up with that, I might experiment with this thing that we don't actually have the passwords for and so forth, but what could go wrong? Yeah, so I'll see if I can come up with any. If I can put a password on it, I will. All right, so she's going to hook up to that. I would say using either the OnAils or the Ruby Central, like still every once in a while, try and clone things or access the website as possible. Cool. So this guy.
I'm trying to think where to start. One of the first things I wanted to do is show you what it looks like to explore a project on Code Climate, but I don't have internet, so I'm not going to do that. This project has a lot of very, very big controllers. It also has some very large models, but the most interesting problem areas in the application are in the controller layer, where, in particular, the controller that we're going to look at has an index method. Let me just get back to my terminal here. Oh no, color scheme, GitHub. Controller. So the index method in this controller looks like it is about 12 lines long. It sets a few index instance variables, but it calls, the most important thing here is that it calls a number of helper methods. And those helper methods are defined in the controller, and altogether they represent 200 lines of code. So this controller action is 200 lines long. And there's a lot going on in here. There is calculation, lots and lots and lots of calculation. There is SQL. There are SQL, like handcrafted SQL queries. Lots of them. And you'll notice also that as we page through here, we keep setting more and more instance variables. So we have, I counted them. It took a while. I think I got to like 35 or 36 instance variables that are set. So you have all of this state that's not visible at all in here. It just looks like we have maybe 5 instance variables. If you go to the view, they're referencing instance variables all over the place, and you really have to know where to look to find those instance variables because it's not in any way obvious in the method itself. What I'd really like to do to make all of this obvious is to inline all of those helper methods. That takes a long time. So if I were, the first time I did this refactoring, I went to the index action, I found every single helper method and every single helper method that the helper method's called, and I just inlined everything and ended up with about 200 lines of code. And then it made it a lot more obvious what was going on here. And most of what's going on here is this sharing of state, this sharing of all of these values that are just kind of floating around in the application between the controller and the view. But the other major thing that's going on here is that we are calculating lots of stuff. And calculating lots of stuff is one of the things that we know belongs in the model layer. That's sort of one of the easy things. It's like, oh, everyone agrees that we can put all the calculations in the model layer. So I wanted to pick just a small portion of this index method, the getStats tags. And when I did that, we end up with a refactoring that's going to concern itself with about 50 lines of code. So calculations, mostly. Get stats tags. There's a really nice comment here that kind of indicates that this is one thing. We got some logic from a blog post. We put it in the controller in a big method, but we kind of isolated it in this helper method. So we can take this and we can isolate it in the model layer. So that's the first thing we're going to do is just create an hard to type and talk at the same time. We're going to create an empty Ruby class in the model layer. And then we're just going to kind of put all this code in there and see what happens. So we don't actually have, right now, in this application, at this point in time, all of the models in the application are backed by the database. Everything inherits from active record base. And this, what we're going to do here, doesn't belong in the database at all, but it does belong in the model layer. So we're just going to create a Ruby class for it. We're in the stats controller, so I'm just going to create a subdirectory for stats, because it looks like there's a lot going on here. The controller is about 800 lines long, so we can probably make quite a few little classes and put this logic in the application layer, in the model layer. It's going to make a directory, and create a new class. So what this 50-line method is doing, kind of crucial, I guess, to mention, is that when you render the index action, you get a bunch of stats about how many to-do items you've completed, how many you've created, and you also get 2 tag clouds. One is tags for all of the to-do items that you've finished for all time, and one is just for the last 3 months. So you have these 2 tag clouds. You have one method that's generating them. It's about 50 lines long. So we're just going to create a tag cloud class and create a compute method in it. And then we're going to go back and we're going to copy all of this. And I just skipped the whole 2 first sections of the tutorial because I was so eager to get started with code. I have more to say, obviously. We haven't run any tests yet. I haven't shown you how awesome the code coverage is in this application, so I'm going to do that first. Whatever. The tests actually take 17 minutes to run, so I'm going to start them, and then we're going to take I'm going to run 2 of the test files because we don't have time to run all of the tests. I'm going to run only the tests that matter for this controller action. It's frozen. Sorry, this isn't reacting. I know. Okay. I actually think I might not even have this right now. Sorry. Have I fallen out? Sorry?
Do you need a connection?
It's fine. Test stats. Okay. Let's see if this works. Okay, so we're running tests. There are a number of unit tests. There are a handful of Cucumber features, and I'm just running the unit test right now. One of the things that I noticed after about 8 hours of refactoring this the first time around was that when I went into the view and deleted the partial with the tag clouds in it, and ran the tests again, nothing failed. Now I looked at the code coverage, and it had 97% code coverage. So it was really well covered. All of it got executed, but there weren't any assertions on it. So the first thing that I had to do in order to prepare for this workshop was to create a test that actually tested the tag cloud. And it's probably one of the ugliest tests you'll ever see, which is typical when you're refactoring code bases. Hi. All right, so I'm just going to reset all of this. Tag.
Can I tell you something funny while you're doing that?
Please do.
I just learned that we're supposed to start at 11:30. You were right. Yeah. I was just overeager. I couldn't wait to begin the refactoring. So sorry if you came on time and seemed like you were late. All the stuff I said was probably stupid. So you got to the good part. I'm like the preamble for Katrina. She's the interesting part. So you're here for the good part. Continue.
Have we gotten internet access yet?
Not that part, no.
Oh.
No.
All right. So one of the first things I did was to create what I like to call a lockdown test. And it's basically a characterization test. A characterization test assumes that whatever is there is working, and it basically generates you take whatever output you get, and then you make an assertion that whatever happens later is going to be exactly what you got the first time. I can't remember. I have to go check the tutorial to see where I'm supposed to be at. I might have this locally. All right. Sorry about this.
Now that everyone gave up, the Wi-Fi works not bad.
So would the first row please start checking out the...
It's actually not that bad of an idea.
Just get the first row started.
First two rows?
First two rows. If you go to the Rails Conf tutorials, start cloning the repo. Once you've got it cloned down, you won't need the internet for the rest of the tutorial. So if you just manage to get it set up, yes. Sorry?
Clone and bundle.
Cloned and bundled. Yes, cloned and bundled. That's correct. So I will keep typing until we've got this show started. But hopefully you'll be able to actually program in a little while. So I created a bunch of tags throughout the whole refactoring so that I can check the code out at certain points of the refactoring. And the first thing that I did was to create this terribly ugly test. That looks like this. It sets up a bunch of data. You don't even have to know what data it is, just assume that it's good. I make a hidden directory. I make a file in that directory. I do some teardown so that we can run the tests over and over again. And then I assert that the page doesn't change while we refactor. And the way that I do that is I freeze time because there's a lot of time-sensitive things. I just render the index page as it is, and I pipe all of what I rendered into a file, which is very, very easy to do. It's a slow test, but it's easy to do. And then I compare it to the previously piped version in the previous file. If those have changed, I raise an error. If everything's good, we're fine, and we can continue. So I also wrote a Rake task to run that one test, and the way you run it is bundle exec rake whip. Whip is short for work in progress. You'll probably see that often when working on tests. This is incorrect. This is running all my stats tests. Which has cucumber features, which will be over in a moment, and then I'll run the real lockdown test.
The cucumber looks fancy.
Cucumber looks awesome. All right. Bundle exec rake test lockdown is the actual test. And that should be only one test. And it fails. And so the reason it fails is that if I open the lockdown approved, this is what I have previously approved, a blank page. Like, we haven't actually approved anything yet, so our approved file is completely empty. If I open the received file, it's got all of the data in it, and at the very bottom we have these tag clouds. And it doesn't actually render any of the CSS, so it's not pretty like the actual site would be. But it's the source of the index action. So the way that I make this test pass the first time around is to just say that whatever I received is now approved. And I can run the test again, and it should pass. And now if I go ahead and delete that partial that we deleted earlier, and the test still passed, stats index, the test should now fail. If the test fails, we have a test that's probably good enough to actually start moving code around. And it's not. I have no idea why. Oh wait, I didn't put the code back. That would be why. App view stat index. Okay. Okay, so the test failed when we were missing the partial. We're good to go. So now let's actually make our class model stats. Oh, we have that. Model stats tag cloud. We had that already. That's very nice. Let's go to the color scheme. Stats controller. And we're just going to copy everything and put it in the compute method. So I still have everything in the stats tag method. I don't want to delete it because I would make my test fail, and it might be a very long path to get it passing again. So the first thing I want to do is just to instantiate my tag cloud and call compute on it, and then see what fails. So the error is going to tell us that we probably missed, there may be constants that we missed, we may be referencing local variables that we know, or instance variables that we no longer have access to, or helper methods that we no longer have access to. And that's basically what this tells us. It says that we're looking for an undefined local variable or method current user for the tag cloud. So we can just go ahead and pass the current user, but we need to take that into account inside of the tag cloud. We're going to create an initializer. And now run the test again. And this should tell us the next thing that we're actually missing. How you doing on that, getting it cloned and set up? Done? All right, next 3 rows. Wrong number of arguments in the initializer. I may have. Thanks. All right, let's map this. One sec. Rake test. Lockdown. All right, we're good. So now we can start. Now we can start actually using the new code. So we have the old code. The old code is what's making the tests pass. The new code, all we know about the new code is that it's not raising any errors. And this is going to be really tedious, so bear with me. It's a lot funner when you're doing it yourself. I'm going to assign this cloud to a local variable. And then I'm going to find the first instance variable here that gets assigned. And I'm going to assign it using my new cloud, tags for cloud. And obviously, I haven't actually exposed this yet, so I'm going to go ahead and expose it. Tags for cloud. And I probably am just assigning the result of my command there, so I'm going to do this. And now if I run the test, the new instance variable that I assigned is overshadowing the old instance variable. So if I did this wrong, the test would fail, but it's passing. So this means that I can probably get rid of this the first tags for cloud. And since I'm no longer using query, I can get rid of that string as well. Run the test to make sure I haven't deleted too much. and it's looking good. And so basically the rest of this screencast is just doing the same thing over and over again. Tags min, cloud tags min. And you occasionally get surprised, think you've done it all good, all correctly. And you get these failures, which is really, it helps keep you on your toes, and it helps make refactoring not the most tedious process you'll ever encounter. So this passes. Let's delete the setup for it. This is one of those cases where we did it wrong. So basically it's complaining that we don't have a variable max. So it turns out all the stuff that we deleted contains this variable here, the local variable max, which is used down here. So I'm going to go ahead and assign the tags divisor, cloud tags divisor, expose it, divisor, run the tests. And if that passes, I can go ahead and delete all the code that we were using. So this is the part of the screencast where you usually fast forward, because we're going to do the same thing all over again. Tags for cloud. And I'm just going to go ahead and do all three of them, even though that's usually a bad idea.
Can I ask you a question?
Yes, please do.
You obviously love this. You are flying so fast. It's so hard to pay attention.
I'm so glad you mentioned that. All right. I feel like the typing is slowing me down, so I'm trying to go as fast as I can. Okay, cool. Okay, so should we just stop and...
We already got like extra half an hour. We started early.
That's right.
Running short on time.
Awesome. Okay, so cool. So in the whole process of creating this test, do you want to walk through what we did and why that's necessary? Cool. So the test suite, when we ran the original tests for this project, it has really, really good code coverage. And it actually uses the simple cov gem. I can actually show you Rake. So I'm going to run the tests for the whole stats controller, that controller that we're working with, just so that I can show you what the code coverage looks like when we look at the output of that. So the code coverage is very good. It's up in the 90s, which means that the tests are, when the tests run, all of the code in the stats controller actually gets hit, actually gets executed. And usually this is a good signal. It means that you've written tests that actually exercise the code. There's a good chance that if you change the code, the tests will break. And the first time I actually refactored this, I kind of trusted that. I didn't do the thing that I've learned to do later, where I go to the top of the method that I'm going to refactor, and I raise an exception, just to see that it happens, or I delete parts of the code to see that it fails. I just kind of trusted that the tests were good. And this bites you enough times, you start not trusting the tests in a project you don't know very well. And most of the tests were very, very good. It was just in this piece of the controller, the tag cloud. Just the tag cloud wasn't really tested. And in the project, it makes sense, because people probably don't pay that much attention to it. Mostly what they're doing is they're putting new to-dos in their system, and they're tagging them and finishing them, and they're getting stuff done. They're usually not going to the stats page to look at the tag cloud of how productive they are. So it makes sense that it's not very well covered. So the coverage ends up in a directory that's not actually saved in the project source. It's called coverage, and you can just open the index page in your browser, And right now, the coverage looks terrible because we only ran 2 of the test files. Yes? This is simple cov. Yeah. So it looks like the code coverage is terrible. That's just because we didn't run hardly any of the tests. We only ran tests for two files. But the where is it? App controller, stats controller. Right. So the stats controller is the controller file that we're actually going to be refactoring. And this is green all the way through. There's very little here that the tests haven't actually touched. So that's usually just a good sign. The method that, it goes on and on. Here we have a little bit. It hasn't been testing the failures. There's one action that's probably not tested. We have a bunch of helpers. So the getStats tag is the helper method that we're actually going to be refactoring today. And it is touched by the tests. And what we did to actually test if the tests for this are good enough is we went into the view and we deleted all of the view code for that feature. And we ran the tests again and the test passed, which is not a good sign. So the test that I wrote is a test that just calls the index action and captures all of the raw HTML output from that action and puts it in a file that I hopefully never have to look at. If I do the refactoring correctly, I'll never have to look at the file. It'll just be there. It'll be, this is the correct version of the output. And then every time I make a change, I rerun a test, and it compares against that original version. And if there's no change, it's good. I don't have to look at it. Now, when we deleted the partial again from the view, we deleted out all the view code for the tag clouds. This, thankfully, failed. So the output, the raw HTML output, requires that the tag cloud code, the source code for that feature, is in the file. So at that point, we have a test that just assumes that the original is what we want, and we can make all the changes we want as long as the new output matches it exactly. Does that make sense? Not really? A little bit?
So if I can recap slightly different way. The premise was that the app was working and it was creating some HTML. And whatever that HTML was is the right thing. And so the strategy Katrina has used here is to output that HTML to a file. And then as we make changes, when we run the tests again, the HTML you get out should match the HTML that we got out before we started messing with stuff. We don't actually care what's in that file as long as it keeps matching. Is that fair?
Yeah, absolutely. So, terrible, dirty hack. Libtask work in progress Rake. I created a Rake file that has some little tasks that will run subsets of the tests, because the whole test suite, like I said, it takes 17 minutes to run on my machine, and I just don't have the...
Can you do a white background easily?
Oh, yeah, color. GitHub. Thanks. So I have a test called Rake test :stats, which just does the controller test for the stats. I have one called Rake cucumber stats, which just does the features for that controller. And then I have one called work in progress, which runs both of those. So the unit or the controller tests that are just the sort of functional tests and the cucumber features. So those are just combined into one. And then I added one task called test::lockdown, which runs that single test, the one that pipes stuff to a file and then goes and checks if the new output matches the old output. And then the test functional lockdown test. That test it's not the most interesting thing. You'll have access to the code base, so you can actually go and kind of figure out the details of how it was put together if you want to do something like it. The main idea is just the most important thing, let's see, is this line here. We're calling the index. And then we're grabbing the response body and just sticking it in a file.
Can you mention what timecop does?
Timecop, yeah. The first time I wrote this, the tests failed every minute, even if I hadn't changed anything, because all of the to-dos are created at and completed at certain times, and the tag cloud is for the last 90 days, so time changes, and then there are timestamps in the page in the footer of right now it's this time, but last time you actually did something was that time. So it was a mess. And timecop is a gem that lets you freeze time. It lets you say that, well, I'm going to assume that it's 2013, January 2nd at 4 minutes past 3 and 5 seconds, or whatever. Just some random time. And I just kind of picked it randomly. Usually I use pi or e, but this time I needed something just kind of sequential and pretty. It really doesn't matter what you use.
So then any calls to Ruby's time libraries will all return that time, even as time passes. Time is now
date,
frozen.
Time now, minutes ago, like everything is relative to assuming that right now it is January 2nd, 2013 at a certain point in time. And this timecop thing allows you to, in your test, say that, okay, right now it's this time, and now I'm going to travel 2 months to the future and check that whatever needs to happen happens. But we're not doing that in this one. We're just saying it's this time we're rendering the page, and every time I render the page, I want it to be January 2nd, 2013.
Generally, anytime you're programming and you're working with time or dates, your life's about to get painful. And timecop makes it slightly less painful by being able to manipulate time, to stop it, to increment it. So you want to move it an hour, right? What's your first thought? Like, well, I'll just sleep for an hour, and then I'll run it on the CI server or whatever. But no, timecap will allow you to say, like, it's this time. Okay, now 1 millisecond later, change it to 1 hour from now, et cetera, and write your tests.
Yeah, there's still a bug in this code, so that at 5 in the afternoon on Wednesdays it starts failing again, and I just have to re-render a new lock file. I have no idea what's going on.
What? At 5 p.m. exactly?
In Denver. When I'm in Denver at 5 p.m. on Wednesdays, it starts failing again. So what I do is I just, if I'm programming at that time, it's like, oh, it's 5 minutes to 5. I just take a coffee break, I wait, and I don't change anything, and I re-render a new lock file, and then I can keep going. I'm assuming it's good again. Yeah, so refactoring is dirty, but kind of fun. So this is what the test looks like. And this is our safety net. And we're not going to ever have to actually look at how that test is implemented. A few times, we're going to get white space differences in the HTML output. And we're just going to say, white space, HTML source, that's fine. I'm just going to copy over the new source. So that's why I didn't just, again, the first version of this test, I just took the whole output of the HTML and stuck it in a variable in the test. It made my test file like 1,000 lines long. It's fine. But then, once I started getting white space changes, I couldn't figure out what the change was. I had a string that was, I don't know how many, thousands of characters long, and I couldn't do a good diff on that string. So I piped it into a file so that I would get new lines, and then I could get actual output, and I would see that, oh, I just have an extra white line, empty line, or this div has been moved over to the, by a few tabs. And then it's okay. Then you can just say, well, it's the same enough, it's good enough, I approve. So after getting all of the test coverage in place, the next step is going and looking at isolating the code itself. So we have this controller action. Let me just change my all right, controller stats.
Katrina likes to use a prehistoric development environment
known
as the Vim.
They tell me Sublime Text is very nice. I might consider it.
She also, for further entertainment, does not use a QWERTY keyboard. In fact, your keyboard is in Norwegian, right?
Yes.
But then you type Dvorak. So, like, you cannot, any key that it says on her keyboard, if you, I'm like, oh, never mind. Like, you will never get the key that it says on there.
We call it security through obscurity. All right. So we have a tag cloud. We have 2 tag clouds. It's a 50-line method. It does a bunch of stuff. That's all we know. It does stuff. And we want all that stuff to be isolated so that we can start digging into it and moving things around and start understanding it, because honestly, when you're looking at 50 lines of code and it's just doing stuff, it's like, I don't know what it does. I mean, now I do because I've refactored it I don't know how many times. But I mean, the first time I saw it, I was like, I just want to get this somewhere where I can think about it in a more controlled manner. And that's what this little Ruby class is all about. At model tag cloud, I just created an empty model. It's an empty Ruby class. It's exactly the same empty Ruby class that you would create if you're creating a teenager named Bob who has a very limited set of answers, or if you're, I mean, it's nothing. It's just an isolated environment that you can put code into, and you'll know that it's not interacting. Like Jeff was saying, that in the controller, it creates a view context, but you'll never actually see it say view context, and it copies over all of its instance variables into the view context. It's scary stuff. Like, there's so much going on there that you just don't know is happening. You can't see it happen. You're not sure when it happens, if it happened. So by putting all of this code into a class that's isolated, you've quarantined all of the possible nastiness, and you know that whatever happens in here is the only thing happening. There's no magic. And it's faster.
You almost never say to yourself, I wish I didn't have all these classes that just are doing one thing.
Yeah.
Right? I wish I could really mash these together into something more awesome. There's a great quote. I think it started from a DHH tweet a while back. It said something like, half the Rails community is afraid it's going to turn it. Okay, let me think. Half the Rails community is afraid Rails is turning into Java, and the other half is trying to turn it into Java. And so I do feel a little bit bad sometimes that the answer is always like put a class on it. But it usually is the answer, like just make a class. That's what classes are for, is to contain a responsibility. And so here, if you have this concept, if there's something you can name and give it a noun, tag cloud, it's a thing. It should be a class. Methods should be verbs, right? So tag cloud has a build method or compute method. If you have a method like the names, if you're writing Ruby-style methods, you tend to betray the missing domain objects when you name methods. When you name a method like, oh, I'm making a method named compute tag cloud. It's like, hey, bro, you got a noun in there. That's a thing. Like, it shouldn't be compute tag cloud. It should be tag cloud.compute. That's how object-oriented software works. Sorry. Yeah. Yeah, don't do that. Don't do that. I don't think it provides you any benefit. you know. The question was, sometimes you see people embed classes within other classes, which, yeah, you can do. It's cute. That's about the only advantage it has. Yeah.
Yeah, often it's just a place so that you can put some of the code you're working on close by, so you have it at hand, and you don't have to be jumping all over the place. And then later, when you figured out what that thing is, sometimes you just don't know what it is yet. You figure out what it is, and then you can move it out. And sometimes it's like, well, I want this thing segregated into its own thing, but it's not really a stable object in my system yet. I don't know where I'm going with it. I don't want people to think it's some stable interface in my application, so I'm just going to leave it here so people kind of are wary of using it from the outside. I mean, they can obviously use anything they like. That's kind of the beauty and terrifying freedom of Ruby. So we create a compute method, and I'm calling it compute because at this point, we don't really know what all of it does. It's computations.
It's a computer. That's probably what it does.
Exactly. So we have 50 lines of duplicated code. And this is my favorite refactoring technique, is duplication. I mean, they say don't duplicate. That's when you're writing fresh code, don't duplicate. When you are refactoring, duplication is a lifesaver because you can put all of the new code in the new place, have all of the tests running against the old code. Everything is working. It's still working. You know the application is working. If you get, you know, a level 5, priority 1, whatever, bug in your lap, you can just check this code in. It's okay. Nobody's calling it yet. You can go and fix your code. All of your tests are running, and you can get back to it later. So duplication is awesome for a while. You have to then actually work on getting rid of it, but that's a systematic and step-by-step process that is not complicated. It's tedious. You know, it's a lot of doing the same thing over and over again, but it's a process that is fairly, you know, well understood, and your tests will be passing the whole time, so you'll be fine.
And to clarify, you copied the code from its original home,
Yes.
And then haven't changed anything yet?
Right. So here, this is the original code. Oh, I changed a little bit of it, but that's because we got distracted and I typed a lot, and then I forgot to talk, and stuff happened. So, yes.
Is there a way to add a deprecation notice easily? Like a deprecation on the original duplicated version versus the new?
Probably.
I'm sure there's a gem for that.
I'm sure there's a gem for that.
I just go hard, just delete it. You know it's deprecated when it stops working.
I try to remove the duplication within like a few hours, just so that it's not in production a long time duplicated. Because once it's in production, it's going to stay there forever and ever. So you have all of this duplicated code, and you're not calling it from anywhere. And the first thing I usually do is just call it. Just to see if it actually doesn't blow up. Because blowing up is like usually the biggest problem. If we had deleted everything in here, and now we were going to try to get all of the whole test running, we have 30, I don't know how many, maybe 10 instance variables that are being calculated. We don't know how. Bunch of calculations, 2 really big SQL queries. Like, there's a lot of stuff going on. So.
And it's very unlikely that, especially on a first pass, you would figure out, like, what are all the parameters that this method is going to need? What are the different pieces of data it needs to do its operation? Our friend Ben Ornstein gave a refactoring talk a couple weeks ago, and I really liked, he changed my thinking a little bit on the process as far as how little time can you spend with your test read. Like, my inclination when I go into a refactoring like this is to comment everything out, and then start rewriting it. And what that means is that I'm probably going to spend an hour, maybe 2 hours, where the tests do not pass. And instead, what Katrina is doing here is, by line 5555 there, calling the new method, and then essentially throwing its results away. Right? She is making it so that it is, at any time to get back to all green, she could just comment out that call, or comment out the other method itself. And so she's always close to green. So run this, and then you see, it's most likely going to have a uninitialized local variable or method within that method, whatever data it's trying to access that we're not passing in yet.
So the first time we ran this, we were just calling compute, and it said, well, I don't know about this thing called current user that you're using, so we just gave it to it. We just give it current user, and that's why when we had to create, I'm going to go like that, create this initialize method, which is not an initializer apparently, initialize method that takes the current user and then give it an add a reader, and that's all. So we just gave it. We gave it the current user. And at that point, we were still not using anything, but we were calling it correctly, and it wasn't blowing up. And that's a pretty good step. Like, that's a good step in the right direction.
It's a surprising progress, I would say.
Yeah. So the second thing is to actually then save the object, call compute on it, and start using it. So, and the way, again, what I was doing is take the first, maybe I should back out of this, I'm not sure. Find the first instance variable that actually gets assigned, and then assign a new one with the exact same name underneath it that uses the new code. And again, this is as close as I can get to being like a second away from green. Like if the old code is blowing up, I can back it out in a second. Like I can be back in control in a very short amount of time. And all I really had to do in order to have the tags for cloud method in the new code was to expose the instance variable, because compute, if you look at compute, it assigns all of the same instance variables that we had in the controller. So after you've called compute, all of those values have been saved into the sort of the internal state of the object, and we can just expose it with an adder reader. And then you're back to just kind of figuring out one instance variable at a time and doing it again using duplication. We're going to duplicate the assignment of the instance variable. We're going to expose that little piece of data inside of the class, and then we're going to use that data, run the tests without having deleted all of the code. Deleting code is sort of it always feels really nice, but every once in a while you're so eager to delete code, you delete too much and you can't remember what you deleted, and you have to throw away, 12 minutes of work to go back to your previous commit and start over again. And sometimes this is a really good thing, because you just learned a bunch of things about your code. But sometimes it's nice to just be able to be one line away from green. So we did this for the first three variables, instance variables, just exposing that piece of data in the class, using them, duplicating that assignment, figuring out that it's still working, deleting the old assignment, figuring out that it's still working, and then moving on. So it's these tiny, tiny steps. And if it goes on for too long, you feel like you need more excitement, because it really is boring. It just works. It's just one thing at a time, and it keeps working. Every once in a while, it throws a wrench in there for you to keep you on your toes. So that's kind of the next thing, is to say, okay, the next instance variable that we have is this tags for cloud, 90 days. And we're going to call it on the cloud again, tags for cloud 90 days. We're going to call it the same thing. And we're not deleting any code yet, and we haven't actually exposed it. We have one called tags for cloud, tags min, tags divisor, but we're missing tags for cloud 90 days. Oops. For cloud 90 days. And what we're starting to see is that there's duplication here. We have one method doing two tag clouds, and they're doing it the same way over, both times. So if we run this.
Kind of clarify what you're saying. You mean that one cloud is both like a 90-day cloud and some other range of time? Is that what you're talking about?
Yeah, so there are two clouds. This one controller method is doing all of the calculations for two clouds in the view. One is for all the tags, for all your to-dos, for all of history, for all time. And the other one takes all the tags for the last 90 days for the stuff the new things you've added or the things you've completed. I don't know if it's added or completed.
Sure. So once you start to have this like domain object of a cloud, then conceptually it's not a large leap to say like, all right, well, I need to have two clouds.
I might need to have two clouds.
I have one class, and then you start to think like, well, in this initializer, I'm probably going to pass in some range of time and then just deal with two instances of the same class rather than kind of having all this logic shared in one place.
And if we try to go there directly, we are going to have 4 hours of pain, and we're not going to get very far. So we're not going to actually just jump to the two clouds. We're just kind of noticing a little bit of duplication. It's like, oh, this looks familiar. I might get back to this in a little while. Meanwhile, I'm just going to kind of slog through getting my instance variables assigned. So run the test. And it's failing.
Wah, wah.
Undefined method each for nil class. This one threw me for a loop for a while. We're calling each on this 90 days, tags for cloud 90 days. We've exposed it, tags for cloud 90 days here. Why do we not have value? Turns out, and I'm not going to put you through the pain of actually debugging that, turns out this cutoff 3 months is an instance variable that is not defined inside of this class. So we're missing, and instance variables are, like, the first problem we had was we don't have a local variable or method current user. That is such a good error message because we know where to find a current user. We go to the controller. We have a current user in the controller. The current, the cutoff 3 months, it's an instance variable that's not assigned. So we have this nil floating around in the system. It's nowhere in the stack trace to be seen, the fact that this thing is missing. So it was, it's one of those things that drives you crazy for a little while. And then you'll see it. You'll go, oh, where is it?
To expound on that just a little bit, like if it was cut off 3 months as a local variable or as a method call, you would get an error of undefined local variable or method cut off 3 months. But in Ruby, if you use an instance variable and you've never set a value to it, you will not get that error. You will get back nil.
And at some point, we're trying to call each on nil, and we don't know why. Yes? So the question is, do I have a strategy for dissecting it? My strategy is flail, pray. It's I kind of do. I kind of go to the last known point that I know where I know what's happening, and I look around near it and see if there's something that catches my eye. And it's a really not a deterministic process.
I think it's a place where especially after if I spent 5 minutes on it trying to figure out what was going on, it's where I would bring in a little bit of tooling like pry or Ruby's debugger, or if you use an IDE, maybe use its debugger and try and walk through execution a little bit, because it's a situation where it's not that there's an error and you can't fix it. It's like you have no idea what's happening. The chances of just stumbling on the fix are relatively small.
Yeah. But this idea of going to the last known point and then looking at each part of the code and saying, well, I know what the value is here. I know where this comes from. I have no idea where this comes from. I wonder where that is. And then you kind of trace your way back. It usually, now if it's not too far away from where you are, that's a good strategy. Sometimes it's not. And I'm afraid I don't have a good. There's a peep code that came out 2 days ago about debugging or troubleshooting. It's next on my list because that's an area it's really complex, but there are definitely strategies that you can use to be more efficient. So the question was, are there any strategies for avoiding that type of error? Yeah. Don't reference your instance variables.
Yeah, don't use instance variables. Yeah.
Even if you have them, use local variables to expose them, and just go through the variables, local variables, or the methods.
Methods, yeah. So I would say in general, when I'm writing a class, I'll try and only use instance variables in initialize, and outside of that, I would I would use them with great hesitation. That just being one reason, I also just think they look stupid. And it's easier if you're, so the alternative here is if you have an instance variable, is to write an accessor method using attr accessor, or just writing yourself def, the name of the thing, and then just return the instance variable. And then in your usage, if it didn't exist, you would get
a good error message that points you exactly to where you need to be. Yeah. So, yeah, sure. So one of the things here, if I say cut off, I guess 3 months, and that's if I can type eventually, cut off 3 months. So we just had a nil problem at cut off. Now I'm going to use this local variable called cut off 3 months. I'm going to see, this might not be the best, this might not do what I'm hoping, but I'm going to try.
I think it should still fail the same way.
It might.
Right.
All right, tags for cloud, undefined method, tags for cloud 90 days. Well, that's interesting. I guess I didn't expose my tags for cloud 90 days.
I think even if it gets the same error, the process of pulling that instance variable out to the tiny little method starts you thinking about, like, what's in here? Like, when did this get set up? As opposed to the original big chunk of code, there are instance variables littered all over, and it's kind of like, yeah, this came from somewhere, some point in the past. I don't think it'll give us, like a magical, better error message. Yeah, because it's still going to return that nil.
Yeah, it's getting nil, and yeah.
But the process of pulling it out, like, helps you notice that it's a thing, that it's a concept in this object.
Yeah.
And we need to set that some other place.
Yeah, so the comment was that it might be nice to have an attr accessor that actually explodes if the value inside of it is nil. Then again, sometimes you want it to be nil, and sometimes it's just a lot of work. So I finally figured out that it was this cut off 3 months, and I needed to figure out where it was coming from. Now I'm assuming it's coming from the controller, because that's where all the state was that we moved into this class. But it could have been, for example, in the app helpers directory. Like in this project, there are helpers, there are view helpers that are using and setting and changing instance variables. So it could, there are a lot of places it could be. Now it turns out that it is in the stats controller, app controller, stats controller. In a helper method called init, def init. This was a really interesting discovery, because we have a before filter on this controller that initializes a whole chunk of instance variables that some, maybe, of the actions in the controller actually need to do their job. So this is kind of a thing that you don't see very often. It's not considered a good practice. It was a surprise that I kind of discovered as I was extracting this.
I've also never seen append before filter as opposed to just before filter.
Right, but it has to happen before everything because it's doing stuff. And
seems like it would be prepend. I don't know, but I think it's also like a lot of what happens in those before filters. It's very common to set one or more instance variables in the before filter, and then when the controller method is happening, it has that shared state, and so it can access those. But that's really pretty ugly, right? Like what you're doing is creating kind of a global state within your controller, and it's just like, oh, this little thing is making his data, and this other thing is making her data, and they just share all their data, right? And you lead to these things of like, wait, where is this instance variable coming from? And that's part of why I said earlier on, I hate the way that we get data from controllers to view templates, because it leads you down the road of like, just instance variable everything. It's cool. Then you'll be able to find it later. Maybe.
If you grep for it.
You're right. If you start searching through your files.
One of the really interesting parts of this init is this @me equals self comment for metaprogramming. I couldn't find a reference to @me anywhere in the project. But they've mentioned metaprogramming in the comment. It might be used, and we wouldn't know. Like, I don't know. I haven't dared touch that yet.
This is just the terrifying line.
Right? It's really scary. But also kind of
for metaprogramming.
Yeah. But what if it's not tested? Like, the tag cloud wasn't tested. We could delete all the tag cloud stuff, and it wouldn't. Like, I don't know that I trust the tests well enough.
I don't trust the same person who wrote this wrote the tests, right? So it's like a little skeptical.
So we have a lot of interesting stuff going on in this init. We have chart widths and heights. We have these primitives, these little numbers, magic numbers floating around in here that get used for a bunch of different things. We have, Jeff was saying that time, whenever you're starting to use time or date or anything, your life is about to get worse. Here we have time, zone, now, UTC.
Yeah, if you want to make time and dates worse, start talking about time zones.
Yeah. Maybe that bug I was talking about, 5 o'clock on Wednesday afternoons, the test fails. It might be somewhere here. I wasn't able to figure it out.
That actually could be midnight rollover in UTC.
Yeah.
Depending what time of year.
Yeah. So I
5 again, but it is mid-90s.
Right. So I started digging down this road, and I started seeing if I could force UTC in the test fixtures to not. I lost an hour of my life that I will never get back. All right, so here, cutoff year plus 3, cutoff month, cutoff 3 months. We've got this one, cutoff 3 months. This is where it's defined. And all we really need is to use it when we actually instantiate the tag cloud. We want to say cutoff 3 months. And then we want to use it in here.
So you're still going to run your init. You're just passing the data that it's been calculated down into the cloud object, cloud instance.
Yeah. So I'm just gonna grab the data I need. Keep running with it. We'll see where it goes. Yeah, please.
Sometimes when I do that kind of stuff, I will check to see if it's used elsewhere.
I do it later. Once I've got everything using the code and working, I often go back and say, okay, now I've copied these variables in. Is it only used here? Then I can delete it. Or maybe it should be passed in, but in a slightly different way. But so the first time I refactored the entire index method, all 200 lines of it, I had 35, 36 instance variables. I think there were 5 of those that weren't actually used in the views. So they could be made local variables. So you can start restricting the scope of things, deleting the ones that turn out to just be cruft from some earlier version of the code. It's really the funnest part of a refactoring is getting rid of all of those little bits and pieces that are left. It's really nice. Sorry? Yeah, it's not a particular time. It's usually when I feel like I'm done with one piece. Like here, I'm still trying to get all the instance variables in, and if I start going down that road, 5 hours will pass and I will have forgotten why I'm here. So I squirrel, I tend to get distracted really quickly. So I try to stay on task, and then when I'm done with a particular piece, I'll go back and delete things and rename methods and whatever. Now I have a failure again. I have no idea. It's the same one. I must be naming something wrong. Cloud, compute. I deleted my compute call. There you go. That'll do it. So I wasn't calling compute. So all of the instance variables that I was assigning were all nil because I had exposed them with adder readers, but they hadn't ever been assigned. And now we're back to a green test. And this means that we can get rid of all of that, and run the tests again to see if we deleted too much or not. And we're good. And so last time we tried to just assign and delete tags min, 90 days. Last time we tried to delete it, that went badly because we actually needed the max local variable, tags min, 90 days. I'm going to just check that the value that I'm getting from the little class is the same value as the one I need, and it is. I'm going to go ahead and duplicate the next one as well, tags divisor 90 days, cloud, tags divisor 90 days. And it's breaking because I haven't exposed it. And I'm now at the very bottom of my controller method. I've exposed all of the instance variables that I need in order to assign the instance variables that the controller uses to pass to the view so that the partial can show this tag cloud. So I can start deleting all of the old stuff here and just kind of tighten this up a little bit. I can delete, so I don't need the comment. This levels thing, I have no idea where it's used, but certainly isn't here. I'll delete the comment. We still have that in the class. So now we have, a few lines, about 10 lines, 11 lines of code. And it's not doing anything interesting, which is good. In a controller that doesn't do anything interesting is awesome. Like it shouldn't have to think about things. It shouldn't have to know about things. It just needs to know who to call and what to give it. That's what a controller should know. It should also know what to assign back from it. And so this is still doing a lot, but it's a lot better. So this is where I commit, because I'm probably going to be making mistakes every few minutes, and it's so nice to have a point where you can just, reset to wherever I was. This is not working out. I don't know what I'm doing anymore. Just reset it to where I last knew that everything is sort of one thing. So I need that controller. I need the app model stats thing. I'm just going to say that I extract tag cloud model. And now I kind of want to go look at that model. Like this is not pretty code. We just kind of dumped all of everything from the controller into here, but we haven't. I mean, there's no improvement in this code yet. I still don't know what any of it does, really. But before I do that, and now we're going back to what you said, before I do that, I want to kind of pick better names for things, because now I'm saying tag cloud dot tags for cloud. Like, there's a lot of redundancy in that. Tag cloud, tags, divisor. We know we're in a cloud. We know we're dealing with tags. So we could say tag cloud tags, and tag cloud tags 90 days. That's definitely an improvement in my view. So tags not for cloud. Now I can't change the instance variable because the view is still going to be using all of those same instance variables names, and I don't want to be touching the view yet. I've got enough to do up here. But tags, definitely a better name. Again, tags min, we don't care that it's the tags. The tags prefix is kind of already taken care of by the fact that our object is called a tag cloud. So we can take off the tags prefix of pretty much tags prefix, tags divisor, tags 90 days, we want that one, tags min, we don't care about the tags min 90 days, tags divisor 90 days. So take off the tag prefix because it's all redundant, it's all superfluous. Min, divisor, and this is one of those things where it's like, there's no good rule for how to name things. There are books written. Did I miss one? Tags. Ooh, thanks. Tags. Thank you. So there's no good rule for how to name things, but I try to read it out loud and say it's a cloud, and I want all the tags for it. Cloud.tags. That works for me. If something has a lot of syllable or a lot of like words in it, if a variable has a lot of words in it, I try to take out each of the words and see if it makes sense still. Like, is this prefix or is this suffix actually providing making a meaningful distinction? And often it's not. It's like input number. Well, yeah, it came in with the method argument thing. It's an input. Do we care? Does the method care that it was an input? It could have gotten the number from anywhere. And as long as it's a number, if it's doing some calculations with a number, it doesn't care in that context where it came from. So that's sort of one of the things that I use, the heuristics that I use, is to just check if each of the prefixes or the suffixes are making a meaningful distinction. Another thing is that this comment seems to be, I don't know if you can see it very well here, this comment seems to be relevant for the whole tag cloud. So I want to take that and just kind of put it as a comment for the whole class. Like, all of this logic came out of this blog post from 2006, and who knows if it's still there, but it's relevant to the whole class. I'm not going to expose the cutoff 3 months. I do want to change the name of the current user. Like, in the controller, it makes sense that we have a current user. It's whoever's logged in. In the model, the fact that this is someone who's logged in a web application doesn't really make sense. It doesn't have any relevance to a model. You might be in the console just kind of checking a tag cloud for some user, or you might be sending out a bunch of emails to all of the users for their, here's your tag cloud for your productivity this last month. And it's not relevant who is the current user. It's just a user. So I'm going to change that from current user to just user. And run the tests, because now I've made a bunch of changes, and that's always a little bit scary. So I've done a little bit of renaming, and I broke it. It's awesome. This happens all the time. Size for nil class. Nil is like my bane. All right, this is how I do this. Hit reset. Hard. App. Model tag cloud. All right. So I just threw away my changes because it's not so painful. I've mostly been talking, but I've only done 90 seconds worth of renaming things. So it's okay to just throw it away. I'm green again, and I can go again. So let's try this current user change, rename that, and see if this still works. And I didn't make a lot of changes, and it still broke, and I have no idea what I did.
Still passed?
It still passed. Mm-hmm. But when I was renaming variables, I changed all the tags for cloud. Tags for cloud to be just tags at one time. And I forgot, and I'm doing it wrong again. I actually changed the names. Sorry. Talking and typing, not a good combination for me. See if we're green again. So I changed the names of the adder accessors without changing the names of the instance variables. So I broke all my code. And because I didn't run my tests before then going on to change the current username, I was like, oh yeah, I'm good. No, I'm not. This is all breaking, and I don't know why. I couldn't remember 30 seconds in the past to know what I actually did. So smaller steps, and like by smaller steps, I mean like one instance variable at a time. It's really surprising how small the steps really can be. All right, so tags for cloud should just be called tags. We're going to do one of those, and run the test again. Of course, now it's going to break because we haven't changed the controller. But it's going to be a lot easier to see that, oh, we're calling a method that doesn't exist anymore. That's an easy thing to fix. We don't have a tags for cloud on the tag cloud anymore. So now, tags for cloud, we don't want to change the instance variables, but we do want to change the method calls or the message sends to the tag cloud. We did it right this time. I did it right this time, finally.
You people didn't do anything.
You didn't do anything. But you should be catching my typos. All right, tags min. Let's go ahead and just call it min, and tags min there as well. And then tags min, just min.
And we're starting to get close to lunchtime, and hope you can appreciate that if Katrina had planned to live code for an hour and a half, she probably would have practiced for like 100 hours. But instead, I was like, hey, can you do this right now while everyone's standing here watching? I think a lot of the time, refactoring, especially if you're newer to Ruby, the idea of refactoring is like, I'm going to take this 8-line thing, and then I'm going to use a ternary, and then it's going to be a 1-line thing, and then everyone will know how smart I am. And most of the time, it's not glamorous. You know, it is this long, ugly process of like renaming 8 variables, and then finding the place where you use those 8 variables and renaming that too. I was kind of thinking, like, are we going to hit the one big, like, pucha? You know, and the answer is no. The great thing that happened here was creating the cloud class. And the more we can push down into that class, the simpler things are going to get. The simpler the controller is going to get, the simpler the testing around it is going to be. Because now it's just the Ruby class. It takes in some data, and it does stuff with that data, and it spits it out. So now our ability to test it, we can unit test it, for instance. Instead of otherwise, the only way there used to be to test this code was to write full integration tests that were testing from the HTML layer. Now that it's a Ruby object, we can toy with it on its own. We can follow Gary and Corey's school of thought and write these tests that don't even load Rails, right? If it's just a Ruby object, we don't need Rails to test that. And we can not pay the 20-second penalty of loading Rails. We could write a test suite for it that loads, finishes in under a second. I think we should probably stop about here, let people get to lunch. I hope Katrina did spend a ton of time putting together the tutorial itself, so when you have this thing called the internet again, I would love for you to give it a shot, try and walk through some of these processes on your own. I think you probably got through, what, like 2, 3 of the iterations?
I think I got through 3 of the iterations. There are 11.
There are 11.
If you have questions, please post issues in the GitHub repo. I will try to update that tutorial on an ongoing basis to improve it. It's kind of long, I think we were at 1,700 lines this morning.
And it really is useful to us because this is a tutorial that we'll probably use again at other conferences like local confs and so forth, where we have more of like a day for refactoring and not an hour and a half, aka 2 hours. So thank you very much for coming. I want to shout out one last thing is tonight we are downstairs doing a Heroku performance workshop. It is a little bit, I thought it was really cool that last night there was the game night. I have this growing feeling that like our conferences need to be less about drinking. Not that I have any personal objection to drinking, but it's like we should have interesting things to do. So I talked to Heroku. We came up with this plan together of like, let's do a little workshop-y, contest-y, hackathon-y thing where starting at 7, promptly at 7 tonight. So the keynote ends at 6:30. Starting at 7, downstairs, 120 people and us, we're going to do 3 little instructional segments, half-hour segments, about like, here is one technique for making apps on Heroku run faster. And really, it has to do with making Rails apps faster. So if you want to make your Blue Box apps faster, for instance, you can do that. And so we'll go through 3 segments. They are using threaded forking web servers. The second one is about caching, specifically like the Russian doll caching you have heard so much about. And the third is looking at database queries, how to optimize those and make those run faster. And then after that, we have a sample app, and you have about 2-hour work period from like 9 to 11:30 to work on that. And it has a performance suite that's going to run in like 90 seconds. And so try and apply those techniques to make it run faster and get it down to probably 30 seconds, which is pretty dramatic change to the end user. And then there's some little like achievements and stuff. If you make it go fast, then you get lots of Heroku gift. I think you can get like $400, $300 in Heroku credits and some other stuff. Railscast Pro, Avdigrim contributed stuff, Word, bring in t-shirts. There's all kinds of stuff. So I think it'll be a fun time to, if you're interested in performance, come tonight. And yes, there will be food, like dinner-y food, not just like, oh, here's a cracker. Hack for 4 hours. Thank you. Have an excellent day.